This is the solution to WEX 390. Okay, so it says f is the one on the left, so I'm going to help myself here and write an f so that I don't get this confused. So f is that one, and g is this one. So we want f of g of 3. So f composed with g evaluated at 3. Without the composition operator, this would be f evaluated at g of 3. Okay, so g takes 3 to 1. So that would be f of 1, because g of 3 is 1. And then f of 1 is 2. Okay, so now we'll do g of f of 3. So f of 3, f takes 3 to 1, just like g, okay. So then g of 1. Now g of 1 is 1, okay. So now this one's kind of interesting. F of 3. Okay, so that means f of 3. So that means that kind of you put 2 copies of f in a row and watch what happens. Okay, so f of 3 is 1, and then f of 1 is 2. Interesting. So now we want f of f of f of f of f of f of 3. Okay, so then that would be, how many of them are there? 1, 2, 3, 4, 5, 6. Okay, so f, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 of 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that's interesting. All right, so f takes 3 to 1. So let's see if we can trace this through here. So just counting. 3 goes to 1, so that's 1 evaluation. 1 goes to 2, so that's 2. So then 2 goes to 4. 4 goes to 3. 3 goes to 1. So 5, and then 1 goes to 2. 6. Okay, so that's interesting. Oh, I forgot what I said. Okay, let's try it again. So I'll try and give myself a slightly nicer notation than this one. So in the first place, we're going to do 3. So 3, and then we're going to give that to f. So that goes to 1. Give it to f again. 1 goes to 2. Give it to f again. 2 goes to 4. Give it to f again. 4 goes to 3. Give it to f again. 3 goes to 1. Okay, so that's 1, 2, 3, 4, 5. Give it to f one last time, it's 2. So as a result, the answer is 2. So f, 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 right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. Okay, so draw f composed with g. And then solve for x. This means that this one is first. And in the typical drawing, if we keep the arrows pointing to the right, that means that G is the one on the left. So as a result, drawing this. So this will be, they're all 1 through 5. So 1, 2, 3, 4, 5. One, 2, 3, 4, 5. One, 2, 3, 4, 5. All right, so then G goes first. So then 5 to 3, 4 to 2, 3 to 1. Okay, then 2 to 2 and 1 to 1. So just to keep the colors clear-ish, 2 to 2, 1 to 1. Okay, now F does its thing. So 5 to 5, 4 to 3, 3 to 1, 2 to 4, and 1 to 2. Okay, so that's the composed machine there, and we want to solve. We want to solve for x. Okay, so then altogether, what we're asking is that how can we get here? How to get to this 5 from any of these. So you can just sort of travel backwards. This 5 goes to that 5, but notice that from here there's no way to get to that 5. As a result, there's just no solution. Okay, and that's a fine thing. That's a fine occurrence. So now, do the same thing, but now we're going to have 2 copies of G in a row. Okay, so then 5 to 3, 4 to 2, 3 to 1, and again 5 to 3, 4 to 2, 3 to 1. Then we've got to do the other one, so 2 to 2 and 1 to 1. So 2 to 2, 1 to 1, 2 to 2, 1 to 1. So now the question is we want to solve G composed with G, evaluate x yields 1. So we want to know how can we get here? Well, again, you just kind of trace backwards. So I see that there's 2 arrows pointing here, so then we can kind of go back this way. So that's, so we're going backwards, and we can also go this way. Okay, so that means that in the middle part of the machine, we could have been a 3 or a 1, and then who's pointing at this 3? Well, that 5 is. So going back this way. So we're saying that if you input a 5 on the left, then 5 becomes 3, which becomes 1. Okay, so 5 is a solution. Now, this how can we get to this 1? Well, we could have gotten there from this arrow. So if you input a 3, then it becomes a 1 and it stays a 1. Or we could have gone this way. So if you input a 1, it stays a 1, and it stays a 1. As a result, the solution is x equal 1, or x equal 3, or x equal 5.